manipulating objects. C. Navigation. Those who are familiar with Maya's navigation controls will feel at home with Unity, as they are exactly the same. Unity does have additional navigation methods on top of them, and we'll look at those as well. To get started, let's create a cube. We'll do it through the File menu. To focus on the object you're interested in, press F. This will create a virtual pivot point around which you can orbit the editor's camera. To do so, press Alt plus left click and move your mouse around. For those on a Mac trackpad, press Alt and move around with a 3-finger drag, assuming you have it enabled in the system preferences. To zoom, right-click and move your mouse. For the trackpad, pinch to zoom will not work. Instead, simply drag 2 fingers up and down as if you were scrolling a web page. To pan around, middle-click and move your mouse. For the trackpad, hold Command and Alt and move around with a 3-finger drag. For those comfortable with the first-person shooter-like navigation, there is also an alternate navigation method. If you hold down the right mouse button, for trackpad users, click the trackpad with 2 fingers. You may move around with the WASD keys. To increase speed, you may optionally hold down the Shift key. Object manipulation. The W, E, and R keys are used for all object manipulation. To translate an object, press the W key. To rotate, press E. And to scale, press R. Notice that for all of the manipulation methods, I can change the object by the individual axis or in combination with all 3. I can also change all of these through the Inspector dialog. If I go to Debug mode by right-clicking the Inspector tab, and go down to the Rotation drop-down, we will see a 4th parameter for rotation. This is the quaternion value, which is an alternative way to animate your objects. It has some advantages and disadvantages, but for now I wouldn't worry about it and just use the regular Euler 3-axis rotation. All the values here may be accessible through a script. Hierarchy. To demonstrate how a hierarchy works, let's create something quick with just the Unity primitives, say a skateboard. Now, you might not want to use this model in your skating game, but using this object as a placeholder is completely fine. Once your model is finished working with the asset, you may replace it with the actual model. A more convenient way to do this, however, is to have Xim provide you with a bare bones geometry, which you can update later on by simply replacing the asset. For the sake of accessibility, I'm going to do a very rough model in the fantastic free and open source app Blender, but you can do this in any 3D modeling app such as Maya. It's important as we go along to give the objects simple descriptive and alphanumeric names so you can later access them in your game through a script. Something that Unity does not allow us to assign are pivot points. Suppose you want your character to perform a manual, a trick where the rider is balancing on the back two wheels with the front of the board suspended in the air, to a nose manual where the back two wheels are in the air and the rider is riding on the front of the board. The board will have to rotate on two different pivot points, or the centers of rotation, from which the rest of the board will follow. You can choose different solutions to resolve this, but for now, keep in mind that you can only change the pivot point in your modeling package. FBX or Collada will also support material linkage, but this won't actually port your material over to Unity, but it will make it easier to manipulate in Unity. There are other aspects for the mesh you need to consider, such as good edge flow topology, optimized poly count, but this should be enough modeling for this introductory course. So let's get this over to the game engine. Now here we have a few choices on what to export the scene with. Unity can read DAE, Collada, 3ds, DXF, OBJ, but the most popular one is FBX. I can simply save this scene and Unity will actually be able to read it, but this is not advised. Unity will read this blend file, but it will do so by converting it into an actual readable format. It will also read Max, Maya, Binary and ASCII, Cinema 4D, Moto, Lightwave, but while this may seem convenient at first as you can just work from the source file, it has some significant disadvantages, such as having to have a licensed copy installed on all of the computers of the team members, importing useless extraneous data, and will slow down Unity. I can bring in the file either through Unity or through the file browser. I don't want to overwhelm you with the import settings, so we will just cover a few of the vital ones for this object. Unity will adjust the scale factor relative to the format. DAE will always import as 1:1, but FBX will import a 10:1 scale. Normals. For now, we will only concern ourselves with face normals, or an indicative line perpendicular to the face that determines its front. Sometimes Unity does not import them correctly from your modeling package, and you may try to use these options to remedy this situation, but you might have to do this through the modeling package. See the manual of your modeling package of choice on how to reverse the normals if this becomes a problem. Make sure import materials is checked, and the material naming is from models material. Leave the material search as recursive up. Notice that we have now an apply and revert buttons. If we click anywhere else, Unity will display a prompt dialog asking if we want to make these changes. I do, so I'll click apply. Updating the mesh is typically done through a version control program when working with a pipeline, but it can also be done manually through a file browser.